There's going to be some feedback. Let's test out the audio. Nope, that sounds great. Alrighty. I gotta pop this chat out. Hey, Ed. Hopefully you can hear me okay. I'm hoping. Just give me a little feedback and then I can start. I really am not a fan of YouTube's live stream preview. Enable live chat. Good, 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 good. Good, good. Let me pop this out one more time. I'm sorry, I really wish I knew how to set up a YouTube live stream before going live, but I really don't know how. But even if we don't get any viewers, that's fine too, although we do have a couple right this second. I just mainly want to record this because today, well, I need to design a computer case. I had already designed one, but it didn't work out, so I'm going to do another one. I was like, you know what? I'll just do it from scratch instead of starting over partially, and then I'll stream it so people can see the entire process. And this is going to be a long video, so feel free to come back later or scan through. And if there's any volunteers that want to edit the video afterwards, chop up and make it a little bit easier to follow, that's great too. I am not a Fusion 360 expert by any means. I'm not really a good CAD designer by any means, but hopefully at least you can see the process, and at least I can get stuff done enough to make some computer cases. All right. Am I even on the right channel? Am I on the NFC channel, or am I streaming again on the wrong channel? Because maybe that's my problem. Yeah, I'm on the right channel. All right, so let's get started. So this is Fusion 360. This is where you would download the software. It is actually free for doodlers, for students, for small businesses that make a certain amount of money. So you can download it and use it for your own personal use, no problem. And there's some professional features which I'm subscribed to, even though I don't actually have to pay for it. I want to support the software because it's phenomenal, but this is where you would get it. All right, moving back over to Fusion 360, this is what you would see when you finally download the software. I'm not really going to go into how to work the software because there's tons and tons and tons of awesome tutorials for the very beginners. I'm just going to show you the process of me designing a computer case. And of course, you can ask questions along the way, and maybe I can answer them, but no promises. But the first thing that I do is I usually will go to my display settings down here, and then I go to environment, and I click dark sky because I don't like looking at a super bright screen while I'm making stuff because I'll get a headache. You also can minimize the text commands here at the bottom because I'm not going to be using any of that. And then Fusion's pretty much set up how I want it to be. Okay, I can't really read right now very well, but I'm going to press C, and I'm also dyslexic, just so you guys know, so it makes it kind of even harder. But Orchomenos, this project is actually going to be, we're going to save it, pop this open, save the design as Sapphire Q4. And if you guys follow the channel, I've been doing a series of mods for Sapphire throughout last year, 2020. They postponed this one for 2021, and I'm actually going to make the case for you guys right here in YouTube. And then I'm going to give you the files so you can go make your own. I'm actually going to be making a case that is, well, I'll show you. It's one that you can go get made yourself. It's not anything too crazy. So I'll move this away, and I'm going to get started. You know, again, I'm sorry for the poor presentation here, but just got to get into the groove, you know? All right. So the very first thing I do is I have to put some parts in. And you can go get the parts pretty much anywhere you want. You can go get them using your standard calipers, measuring your parts, which is what I do. You can download some stuff on GrabCAD, but be careful because you can't trust the dimensions. You can go to different websites that have 3D repositories. And you can go to my Patreon as well, where I have lots of parts available. Boards and cards. And we're going to start with a mini ITX motherboard. I'm actually going to change my view to the top. It's a little bit laggy because I'm streaming and recording and all that jazz. And the first thing I do is I position all my parts. I arrange them, I get them how I want, and then once that's done, then I can start building the case around it. And I'll cover all that Orchomenos later, but basically this is going to be able to be made by Cut Send, no problem. For the graphics card, I'm going to start off using this graphics card I have in here. Again, you can get all this stuff from my Patreon. Or, you know, just measure it yourself and build it in CAD. I'll probably be making some parts here on the stream as well. I've noticed a bug in Fusion, at least on this operating system, where you kind of got to tilt the camera sometimes to get it exactly where I want it. Two millimeters actually looks pretty good over there. And I know I'm going to need some space for the PCIe key. I want to limit that as much as I can, like the Mini, but that's going to be a little bit too much because we want just enough, oops, my bad, where the I/O cutout sheet is not going to overlap the PCIe tabs. So that's going to be about right for me. Next, we need a power supply, and for this particular build, I'm going to be using an SFX power supply. Hello, Raystum, and I would love to give a big hug to my friends in Brazil. I usually work with music in on the background. I don't really want to put something on though and annoy everybody, so I guess you all can use your own music. I might put something on. And if it bothers people, then you can let me know. All right, that's a lot better. All right, so I know that the cable for the SFX power supply is going to extend out about 25 millimeters. So I need to make sure that I am offsetting the power supply a little bit. I'm going to do 20 millimeters because I know I need at least 5 millimeters for the cutout of the I/O shield right there. And I know that I'm going to need a little bit of space right here on the edge of the board for my 24-pin connector. You know that little clip that goes on the end? I'm going to need some space there. So I'm going to actually offset this by 4 millimeters. It was already a little bit offset. I'm actually aiming for maybe 10 millimeters total. Thank you very much for the donation. I can't read kanji, so I can't give you a shout out, but I really do appreciate it. Not that I could read any kind of non-roman. Well, I could probably read some romanji out. I don't know what it would be, but you know. Hey, look, the subscribe button is right over my face. I didn't notice that. I don't even know I had a subscribe button. Let's move this over. We don't need this area right there. This might actually be a little worse because now you actually have to look at my face, but let's see what that looks like for now. Okay, I have my power supply about where I want it as far as the top-down view. So now we have to move on to the next component. I don't need to worry about the CPU cooler right now. I'm not worried about that at all because I'm pretty much going to let the graphics card height dictate my CPU cooler. Plus, I'm also thinking about doing a window here so the cooler can stick out a little bit if it really needs to. Well, MacuWack, you must be a savant if you're able to read some of that anyway, so. Okay, so now we're going to deal with my other views, because obviously, just because they're in plane on the top, which is Z, they're not going to be in plane. Actually, no, this would be X and Y, because I'm looking at X and Y. Now we have to deal with Z. So let's move the power supply. And we're just going to do it really rough for right now, because for reasons. I'm going to stick this right here. We have more parts to jam in. But then again, this is pretty close to what we're really needing here. The other little ancillary parts we can add in as we go along. I'm mostly concerned with the graphics card position and the power supply. But what I am going to do is I'm going to throw in a higher detail model of a graphics card. Now, normally you wouldn't need to do this, or you shouldn't actually do this. You should take the graphics card, the model that you have, and then extend it out. Keep it really simple because it's easier and faster to design that way. But I have this model. I don't have the actual card with me, and I need to pull some dimensions off of it. Hello, Hector. Greetings from America to Chile. This is a really big file, so that's probably why it is lagging out. And hopefully Fusion doesn't crash on me, but... I thought I had a lower poly count model. Kevin says, I've been wanting to do this myself for a while, but my 3D modeling skills are just not up to scratch. Well, this is a good opportunity to get back into it. And plus, my 3D modeling skills are definitely not up to scratch either, so if I can do it, anybody can do it. Although, like anything else, it just takes a little bit of time. There are tons and tons of resources for Fusion 360 on YouTube. I'm going to be covering maybe a few Fusion 360 specific manipulation tools, but for the most part, I'm mostly concerned about the process of designing a case in Fusion 360. This is the fun part to me. It's also the easy part. It's just figuring out where your components go. Now, usually I would do like an align, or I could use a move to point, but I know that this model and my measurement model don't line up. I actually think my measurement model is more accurate, so I'm just kind of ballparking it. Because I don't really care so much about... What I care about is the relationship of the GPU bracket to the GPU, since this GPU model I have does not include the bracket. I'm also not going to be using this. This is a Sapphire Nitro 5800 XT, and I'm going to be using a 6800 XT for this build, but they're pretty close in overall dimensions, so I'm just going to be using this. And of course, I'll double check before I finish up. Excuse me. Hello, Eric from Atlanta. That name sounds familiar. Okay, so now that I have that, I can hide my main body of the GPU. I'm not going to do that though. I'm going to focus on the position of the GPU in my Z space. But to do that, I need a floor. I need a floor for my computer. I think that I want to use 8mm standoffs. I think that works really well for me. I think I have some 8mm standoffs. But before I go do that and have to go make a bunch of changes, I'm going to go get my 8mm standoffs out and measure. When I'm designing in 3D, I usually have a table full of parts, and I have my calipers with me, so I can just double check and make sure that everything is correct, because I don't ever trust models I downloaded from the internet. Dang, these are 10mm. Wait, no, my calipers are just... No, they are. What? That is not correct. Oh, I see what I did. I see what I did. I ordered one of those packs, I guess, that had multiple lengths. All right, perfect. 8 millimeters. I like 8 millimeters for custom cases for this reason. If you are designing a computer case for mass production with proper tooling, then you can kind of pick your own standoff height, although I'll let you know that it gets to be pretty expensive for like a console design. I can't go into that right now. It's actually one of the reasons the Mini is very special. It becomes more and more difficult. So you want to have the I/O shield and the bottom plate, which I'll cover this later, far enough apart so when you're bending the metal, you get a nice, clean, crisp bend so the machine has something to grab onto. I found that 8 millimeter is pretty much the lowest you can go for really simple bending machines. So what I'm going to do is I'm actually going to create a new component. And it's going to be a subcomponent of Sapphire Q4 version 1. And I'm going to call this my 8 millimeter standoff. So I have my component made. Now I need to actually make the standoff. So I'm going to create a sketch. And I can use the bottom of this motherboard. And I thought I already did. I guess it lagged out. I want to capture the position. And my standoffs are approximately 5 millimeters across. And I'm going to extrude it by pressing Q, making sure that my sketch is selected, and extrude it by 8 millimeters. So now I kind of know where my floor is going to be because I have my standoff on my motherboard. MackeyWack says, some more considerations for the manufacturing process. Tooling limitation. Yeah, that's a very big deal, and that becomes a major problem as we move forward in the design. To start off with, I'm just thinking ahead and thinking about, okay, what things do I know I need to do when arranging the hardware? The actual specific tooling stuff we can work out as we're making the individual parts. But I know that I want this to be able to be made by simple bending processes by you guys ordering it from a company like SendCutSend. So I know that I need to have a good amount of space for the I/O shield to be raised up from that bottom bend. So I know that that's going to be 8 millimeters. Of course, you can go higher than that, and you can put stuff under the motherboard, like if you want to put some drives on the motherboard. It's totally up to you. And I will be including this file for download when we're done here, so you guys can make any kind of modifications you would like. So now that I have that out, I know that my power supply is going to sit on the floor of the case, so I'm going to move my power supply down. I'm actually going to use the point-to-point feature. Well, I'm not going to do that because I already set it up before. But you can see it's about a millimeter off, so I'm just going to put it down by 4. It's fine. It doesn't need to be touching the base completely and totally flush because we are going to bake in clearances for all the screws. You never, never, never want to make a computer case that you're kind of making by hand or with simple tooling to the exact tolerances that you'll look up online. You want to go extra, extra loose for every part and panel and component. It will look really big in the computer, the gaps will look nasty, but in real life you won't notice it at all, and it will really make things handy because in the real world, things do not come out like they do in the computer, and that's something that's very important to learn. Otherwise, you could spend a lot of money fixing this stuff. Giame Albert asked, where do you find the detailed 3D models? And I make most of mine. The vast majority of them I make because you can't trust anything that you didn't make yourself. However, you can download a lot of models from GrabCAD. You can download models from repositories on BitTech or smallformfactor.net, from my Discord, and from my Patreon. I include a lot of the files that I make in YouTube videos there, including this will be available on Patreon. This will actually be available to YouTube peoples when I'm done. So you'll be able to use these models if you'd like to. But that's how you get the detailed models. I actually do work for Sapphire, design work for Sapphire. So a lot of Sapphire cards and GPUs I have. I can't share this actual Sapphire GPU detailed model with you. However, I will be sharing my other model, which I'll bend to the correct size. Because this isn't my IP, it's just I'm contributing to it. Der Spartner says, I really like my channel. And greetings from Germany. Well, thank you very much. I appreciate that. And thank you for everybody that's telling me hi. I really do appreciate that as well. Guillermo asks, will have a gun compartment. And no, this particular computer case will not. It is going to be designed in America, in the South, but it's not going to have a gun department. Good question, though. Okay. I have pretty much the basics of what I need for this computer system out, so I'm actually just going to start lining up the shell. A lot of other components later that are going to dictate cutouts and details, but for right now, I just want to get my shell made. But what I'm going to do first is I'm going to create a new component, and I'm going to actually make this my, like a folder. I'm going to dump all my hardware into it. Now, luckily, Fusion 360 allows you to move components around on your tree now, but when you first had to start working with Fusion 360, you couldn't do that. So they had this thing called the, I forget what it was called. It was like the first rule. I think it was called rule number 1. That's what they called it. Really simple. And so if you're watching Fusion tutorials, you'll hear about that. That just means as soon as you open the document up, create a new component and then start modeling in it, because you couldn't move things out of your main component. I'm going to save it after this too so it doesn't crash. But if it does crash, I have some backups that we can work off of. Man, it's really thinking. It's doing something. I think what it's doing is, see at the bottom, it's building out the design history and it's dumping it into the folder I created. Okay, so now I have my PC hardware in a folder, so I can just turn it off and on if I need to be able to do that. We are going to actually make the very first part of our case. It's going to be a very simple case. It's going to be basically a 2-piece design for the main frame. And then I'm going to add things later to it, like a side window, a stand. I don't know. We're going to have to dress it up. It has to be cool after all. But we're going to start with a simple 2-piece clamshell design, which I found is the very best way to cheaply get this computer case made and have it go together easily and simply in your own apartment without special tools. So to do that, I'm going to create a sketch from the sheet metal tab. I'm going to hide my data panel right now. Go away. Go away. Okay. I'm going to create a sketch. I'm not going to click on any of these components. If I do, it's going to want to make a sketch based off of the sketch that's already there. That'll mess things up. So I'm just going to click anywhere outside of my actual models. Now again, I'm not an expert in Fusion 360. I can make stuff with it. It's probably not the best way, so learn the best practices. But I think this is mostly correct because it does seem to work all right. All right, so now that I have my sketch icon, I'm just going to simply drag a rough box around the area of my computer components. And the only thing I'm going to do is, I'm not even gonna, no, I am. I'm not going to leave the units. I'm only gonna have, I'm not gonna have any decimal places. That's the only thing I really care about right now. So I'm actually gonna make this 350, and I'll make this 360. That means later when I'm adjusting the width of the case and the depth of the case, I know I won't have any fractional units. I can just easily say -5 plus 10. It'll be fine. It'll work out okay. Okay, cool. Now I have my little sketch here, and I'm going to do something that's really fun. I'm going to make it into a sheet metal part. And to do that, I go back over to the sheet metal. It's moving so slow because I'm doing all this streaming stuff. All right, I'm going to click Create Flange, the very top. Click my sketch, and now I have to punch in my rules, my sheet metal rules for how I want the metal to be. That's going to tell the computer how it's going to fold, how tight the bends are going to be, where the relief cutouts need to go, all that kind of stuff. Fusion 360 already has a bunch of this information built into it. So you don't really need to know everything starting out. You can go experiment if you want. I already have some stuff. I just need to find my correct thickness, and my little window here is kind of bugging out, which is annoying. I think it is this one. Aluminum, 2 millimeters. 2 millimeters will be really, really thick for this computer case. You really want something, 1.6 would be fine for this design, but honestly, if you're bending it yourself, you want to use as thin a material as you can get away with. I have gotten away with this particular clamshell design doing these experiments with 1 millimeter aluminum. That's really thin. 1.6 would be ideal, but if you get a crisper bend, you're going to want it to be thinner material. And this applies pretty much everywhere, but of course, if you have a really nice machine, or you're paying somebody with a really nice machine to do it for you. My machine can do 2 millimeters, but I think I have another one somewhere that's the appropriate 1.6. The good news is I can go back anytime I want to and change my sheet metal rules. I just can't see what I'm doing. It's very strange. Maybe if it doesn't allow me to move the box out, which is not normal. Okay, so I have a 2 millimeter thick panel. 2 millimeters is the thickness of the S4, the Skyreach 4 Mini cover panels and the front bezel. The rest of the Skyreach 4 Mini is 1.6 millimeters thick aluminum. So for those tight, thin bends, it's 1.6. These are going to be, it's going to be a really simple bend, but again, I'd prefer 1.6. I'm just going to start off with 2.0, and I can change things as I go along. I didn't like working with that weird window. It was kind of bugged out. Now, what I did do something wrong here. I created this sketch inside of my PC hardware. I did not mean to do that. So I'm actually going to go back real quick. I'm just going to undo what I did and redo it really fast. All right? Because I do not want to do it that way. I want the design history in a separate component. Okay. My bad, guys. So I'm going to click the main component up at top, my main workspace component. It's lagging so bad. Create a new component, and I'm going to call this I don't know if I want this to be sheet metal component, but I think it'll be okay. I'm going to call this the top cover. And I know that I want to be this. Okay, cool. That's activated. So I'm going to create the sketch, click outside my workspace. Make this 350, make this 360. And I'm going to make my flange. Okay, we're back to where we were, but this time I have my own little component in the bottom, or I don't know if you can see this on the left side, the top cover. And it's going to keep my design history nice and neat here and not break anything else as I'm moving between components. So I want that all separate. I'm actually going to start to move this now. So I'm going to take this, I'm going to move it. I'm going to move it into place underneath my standoff. I don't care where the other parts of this are, but I'll move it just underneath the standoff. Now you'll notice that there's a little microscopic gap. And you might say, okay, well, maybe Josh, you want to actually make sure that it's touching the face so you can use point to point and get right up against that. I'm not worried about that right now. Again, there's no possible way you could even see this with the human eye in the real world. I'm going to use joints to put everything together when I'm done. So I'm just going to get kind of where I want it. I'm not going to cover the same concepts over and over again, by the way, so don't worry about that if I seem like I'm going kind of slow. All right, now I'm going to position the edges of my sheet however how I want them. And I can move it out, and I can just click where I want it to be. So now this line is in line with the motherboard. And I know that I want space here on the side of my computer case. I need at least 5 millimeters minimum from the I/O shield to the edge to even hold that I/O shield in. But really, what I want is something a little bit more beefy. I'm going to actually do 10 millimeters. So now I can click a new offset. I'm going to punch in 10. And now this face right here is 10 millimeters from my motherboard, which is exactly where I want it to be. So I'm good there. I know that's how I want it. I'm going to make the other flanges 10 millimeters when they're going over. That's cool with me. 10 millimeters, in my opinion, would be the minimum that you could easily assemble this computer case for. Anything lower than that, it's going to be quite difficult getting it around this motherboard. And it's also going to cause tear outs when you go to bend without, again, special tooling. Let's do the other side. Same kind of thing. Drag it just a little bit, and then I can snap it to whatever face I want, and then we're going to use this edge of the graphics card. I don't know if Eric is still in the chat, but I can make him a moderator. And now he can invite people to the Discord, and he can send people links and stuff like that. And if there's anybody else here that wants to be moderator who I know, just chime in. All right, that's fine. I'm going to do the same process again. But this time, I know I need a couple more components on the side of this graphics card. So I'm not going to finish this one just yet. I'm going to move on from that. I'm going to go to the front now. Same dealio. I know that I need 6 millimeters total from the power supply to the front in order to wrap the cable around. So I'm going to actually do 6. And I'm going to see what it looks like if I can get my graphics card even in there. What's that look like? That's going to be really tight. That's like 2 millimeters. And again, we always want to have plenty of clearance. So I'm going to go to 10. Let's see, the flange is going to come up over here. I'm actually going to go to 15 because I want to really be able to easily stick this graphics card in without having to angle it underneath that flange. Yeah, I'll be happy with that. All right, now we're going to do the back. The back is really simple. because we want it to be completely even with the I/O shield. So I just click the I/O shield and we're good to go. Hello, Jonathan. Good evening. Linty says hello. Hello. And if people could help the chat as well and let them know things I covered, like where to get the 3D models and stuff, that would be fantastic. Eric, that would be really helpful if you have nothing better to do. I know that you have an exciting life, but maybe kick back and help these peoples out. All right, this is where the computer case really starts to come alive to me. To you guys, you'll probably still think it doesn't look like anything. But before we do that, actually, no, I need to do one more thing. Sorry. I'm going to pop open my design library full of parts that mostly I've all made by hand. A few of them I've downloaded just for rendering purposes, which you can get stuff on GrabCAD. And of course, I have a bunch of files on my Patreon. I'm going to be going over to power supply, and I want a C6 connector. Now, a lot of people say, well, why not a C14 connector? Because the C6 does the exact same thing as a C14. I'm going to include the cable with this to whoever wins this thing, because Sapphire is going to give it away, the whole computer system. So I'm just going to use a C6 connector for compactness. Oops, I did this completely backwards, but that's okay. And you'll notice I did this wrong again. I put it inside my sheet metal component, which I don't want to do. I want to keep all of my components in the correct folders. But luckily, again, I can move it with this version of Fusion 360. It's just going to have a design history saying I moved something. And I don't really care where exactly this is, but again, I know that I need to have some clearance. This is a couple millimeters. That looks about right. How this graphics card is installed, I don't need to key it in. You'll see how it's installed later, but I got to keep that into consideration. Like most graphics cards, right, you need to slide it in from the side to mate with the GPU tabs on the case. So I couldn't put the connector here, right? Because I would not be able to install the graphics card. I'd have to put it way out here. But I have a special idea for how to mount this graphics card so I can actually get a lot more clearance. This particular graphics card has the PCIe power connectors sunk into the card, so I don't need to have a lot of clearance coming out the side for cables, but I do need a little bit. And that's why I love to put the power connector on the same side, the AC inlet on the same side as the power connectors of the GPU, because I'm not wasting space that way. I know I need to run cables on this side of the graphics card anyway, so I'm not actually wasting a bunch of space. I think this is fine. I'm going to leave it here. I need at least 16 millimeters for my on-off switch, which I might not put in the back. I might put in the front, but just to be safe, this is 19 millimeters, so I have plenty of room because a 16 millimeter on-off switch has a 19 millimeters front head, so I just got to remember that. And I'm going to extend out my top cover. My bottom cover to make sure that I'm going past, obviously, my C6 connector. And I'm actually going to go to the C6 connector, and I'm going to go out 5 millimeters more. I think that will look fine and dandy. I don't know how loud the music is. If it's really loud, I can turn it down. My brain can't concentrate without something in the background, so just let me know if it's really bothering you guys. Somebody says, can I ask you a question? And of course you can ask a question. That's what the chat is for. All right, now to my favorite part. That's starting to make flanges. I want to hit capture position, otherwise it's going to go back to the original position that the design history record the part in being. I'm actually going to hit cancel because once again I got distracted and did not select my actual part. All right, I have my edge selected. This is the part that's so cool to me. I can now drag to create my flanges. I don't want to do this particular one. I'm actually going to do it from the back. There we go. And up we go. I'm not particularly caring about how tall it is right now. I don't think I do anyway. I know that my graphics card is underneath the power supply. 70 millimeters is actually a pretty good height for this. So I'm going to leave it at 70. And you'll notice that I'm on the inside of this I/O shield cutout, meaning that when I pulled up my flange, it's now absolutely flush with the outside of my PCIe And I don't want that. I want it to be on the outside, but you can see right here, I can have that option. So if I click outside, boom, it automatically adjusts using the sheet metal bend rules to go to the outside of my I/O cutout. I can also do, here's what the inside looked like. Inside, outside, and I can do adjacent and tangent. That's not going to show up really well here, so you'd have to experiment to see if that's actually what you wanting to use for your design, but I'm going to click outside for this design. Censored Eric, that's hilarious. All right, so now I'm going to make a flange over my graphics card. And this flange, I have an option for, well, I'm going to do it this way first. I'm going to pull it out. And if I make it 10 millimeters, keep in mind that's including the distance of the bend. Okay? It doesn't mean the flat part's 10 millimeters. And I might want the flat part to be 10 millimeters in order to put an M4 screw in, for example, to center it. I'm actually going to be using 12 millimeter flanges all around, especially since I gave myself plenty of room. I just need to make sure that I have 12 millimeters here and here when I go back later. And I think I'll be fine. Worst case scenario, I go back and make a small adjustment. Now, the full edge means kind of like what it sounds like. Notice how the bend went all the way to this edge and it went all the way to the other edge. For right this second, I'm okay with that. But later I'm going to have to want to go back. I'm going to hit a two-sided edge like this. I'm going to actually adjust where I have that flange going in. I don't know exactly where it's going to be right now. But when you see when things fold up, I need to have a space there. But I'm just going to keep it full edge for right now, right this minute, because I don't exactly know how I want it to look. Now I'm going to do the front, and the front's going to be really easy. Doing the exact same thing. I know this is 70. At least I think it was 70. Hit OK. And I'm going to do the other flange at 12 millimeter. I'm going to go back and we're just going to check. Okay, great. We're clearing the top of the power supply here. We're clearing the graphics card, no problem. We have a nice beefy flange. That is, the flat part is 8 millimeters across, which is perfect for centering my hole, because I might want to put M4 screws at the very top depending on how it looks. I'm not sure yet. I might assemble the whole thing with M3 screws, but we'll see what it looks like. Hey, Jonathan. You are most welcome for any kind of advice that you are looking for. Eric keeps getting blocked, and he's the moderator. That's hilarious. Hector is asking, if possible, would you make all the fans facing the same direction? I actually could for this design. Maybe I'll do that for this design. The thing about it is, I've made many videos on this topic, and I don't want to get sidetracked, but having all the fans on the same side doesn't make the GPU run cooler. So fans overcome natural convection, right? Like, that's the point of fans. So it doesn't matter if your fans are facing up or facing down. Really what matters is, are your fans covered or not? And if I flip this around, the back side of the GPU is going to be covered by the ribbon, and then I'm going to have the key on the left side of the GPU, which is going to make me have to extend everything out even further. Because right now, you see, we're actually hacking physics a little bit. That's kind of a stupid term. But you see how the PCIe tab, the key and the tab, are going over the motherboard? So we're saving about 13 millimeters of space in this direction by having the graphics card flipped this way. And 13 millimeters doesn't really sound like a lot until you remember that it's cubic. We have to take into account from front to back. So we're talking a really significant portion of volume for flipping that graphics card up the other way. And if we make it, because we want the sorry, the build to look good, okay, cool, we can make that design choice, but I want the graphics card to be visible from all sides. We'll get to that part later. So I don't want to cover the graphics card with a cable. I want the back to be completely free, and I want the front to be completely free. So this particular design, I'm going to have it face opposite directions. However, in my Patreon, I do have a case that is modifiable to have the GPU flipped either orientation. So you can choose which way you want to go. And you'll be able to modify this file very easily, so you can make the decision for yourself. The Terrible Gamer says, greetings from Moss Point. I could take this Gatorade bottle and throw it and hit your roof. That's pretty cool. So it's good to have another person in my neck of the woods on the stream. Mattias says, if I change a component on the motherboard, do I have to format the BIOS? And no, you absolutely would not have to do that. You just need to make sure that Windows is going to be compatible with whatever component you're sticking on there. Like if you want to change the Bluetooth card out or the wireless card, that's the only issue. Right now we have our basic clamshell part design for our bottom of our case. So I'm actually going to make the top cover now. I just called this a top cover, but it's clearly the bottom. Call it the bottom tray. I'm just going to call it the tray. Bottom tray is kind of redundant. Great. Nope, no. Got to go back to my original file. Select it. I'm going to save it before anything crashes. Mr. Zeng asked me if I can put the C6 connector above the motherboard and if I would save some space. It won't fit with how much space I have here now, but certainly if I want to increase the height of the case, I could do that. The one thing I have to take in consideration, though, is the C6 connector is in line with the cables for the graphics card, which have to come out and bend down, and they're going to be sleeved. So I do need to have space for those anyway. So I'm not actually wasting any space by having the C6 connector on the back for this particular design. All right. Tomo says, how long would it take someone to speed design a case? I don't know, but I can tell you now that I've not made a lot of progress since how I started, but it's very difficult for me to talk and model at the same time. And Michael says that somebody lives in Gulfport. He lives in Gulfport. Man, I got people on both sides of me. That's crazy. Jonathan says, gotta save it before everything crashes. Yes, I've lost a lot of work. Luckily, Fusion keeps backup, so I've never really lost a lot of work from a crash before, but it does, I have to recover it, so it's just a waste of time. It's much faster to save it this way and open it back up if I need to. Fusion, I feel like, was designed for the Mac to begin with, and it's really difficult to lose data on a Mac. Apple just caches everything in the background. And Tomo asks if there's any reason for Fusion 360 over SolidWorks or Inventor. Inventor is very complicated, high-level, difficult to use, I would say. I start off learning Inventor, and I designed my first production cases using Inventor. It's also very expensive, I think, now. I don't know if they've changed that. So I wouldn't recommend Inventor to people watching the stream who are beginners. SolidWorks is actually fairly simple to use, even though it's a very professional program. Very similar to Fusion 360, but again, you have to pay for that. Fusion 360 is free. It does everything that you could possibly want to use for building a computer case, and it has really cool tools built into it that the other programs might have to use plugins for. It's been a while since I used those other programs, but I can have CAM built right in, simulation built right in, animation built right in, rendering built right in. That's why I call it Fusion 360. They take all the tools that you really need, make them very simple to use for dumb people like me, and put them all in one program. So definitely, and it's free, again, for hobbyists. So Matt asked what liter this case is going to be. I'm going to guess it's going to be about 8 liters total. But we're going to see. I'm going to get back to it, though. So, yes, create a new component. Sheet metal component. Using the same aluminum sheet metal rules. I'm going to call this the cover. Now we could take the bottom tray, duplicate it, flip it around, and it would probably mate up. But we're not going to do it that way. I'm just going to quickly make the cover and not talk about what I'm doing because you just saw me make the tray. Oops. No, I don't care about that for this particular instance. Finish sketch. Make my flange. I'm going to position my flange. Got a little lag there and reset my This is, again, on the outside. I have to determine if I want that look on the outside or if I want it on the inside. I want it on the outside. but I could just as easily make it on the inside if I needed to. I got to bring it to the floor. You notice when I click on the floor right here, it doesn't go all the way down, and I believe that's because, yeah, it wants me to go all the way to the bottom, and then when I bend it out, it should make the appropriate flange. Let's test that though. We're going to hide the tray. And we want this to be 12. All right, and you can see that our flanges mated how we wanted to do. We wanted to touch that bottom tray, and it did. So let's do the other side. I think I said 72. Did I click inside for that one? I want to be on the outside. Yep. So I can actually show you this Fusion 360's design history. I accidentally clicked inside, so my bin's on the inside. I want to be on the outside. So what I'm going to do is I'm going to go down to the bottom of the screen, and I can actually right-click on the last operation that I did and click Edit Feature, and I can make it outside. And that is why Fusion 360 is amazing and why you don't want to be using something like SketchUp. Because once you do something in SketchUp, that's it forever. But I can go back any point in time at the very end and make a small change, which is really, really neato. And I have to make my flange, which I think I might have messed this up already, but again, I can go back if I need to. And I think that's correct. Cool. So now I have my computer case. I'm done. I'll see you guys later. Not quite, right? Now we are going to make this look good and make sure it's actually possible to put together. So I think that the first thing I noticed, let's change the opacity of these. Is that my flange kind of went underneath the motherboard. And I don't want that. That's going to be difficult to assemble. And remember, I don't want to be difficult to assemble. I want to have lots and lots of room for activities. Because I have so much room on this side, I don't think this is going to be a problem. But I did want to check it and make sure. If we go down to the bottom here and we hide the tray, we can see that we have easy access to the holes in the motherboard to mount it. So I'm not concerned with this flange being so close to the motherboard. However, again, generally speaking, you want to look for stuff like that and go, oh, that's too close. I do want to add a little bit of a gap, like 1 or 2 millimeters. But again, I have so much on this side. I don't have anything butting up against it. I'm going to be able to easily put this case cover on. I might have to do it from one side or the other. Plus, there'll be a little bit of flex, right, until it bolts together. So I'm going to be fine there. Let's look at the front. Still looking good there. I'm going to hide the cover. I'm going to go back to the tray and make sure that everything's lined up correctly. And it is, except for my C6 connector. Easy peasy. Hyperion says you can use inspect section analysis to slick a whole design with opacity and tweak. That's cool. C. Hassman asks, what's my bin radius for 2mm aluminum? Well, I don't remember, but let's go look at it and find out. That's a good question. I've already set all this up previously. What is it? Oh, that's really nice of you. But I'm doing a stream right now. Say hi to everybody.
Hello, internet.
Okay. Okie dokie. So hopefully that gave you enough time to see what you need to see there. Now we're going to make my bins actually look good. Because right now, not only is it literally impossible for these two pieces to go together, even if they did, they look like garbage. Look at that. This looks horrible. Obviously, they can't go together because they're doing this whole horrible nonsense. And we don't want that. We don't want that at all. Yeah, okay. So I'm going to do a couple things here. One thing I've kind of forgotten how to do, so I'm sorry for that. I'm going to have to figure it out. But I want to basically make this section of my bend extend out and meet the back end of this face, so to cover this gap. The second thing I need to do, which I know how to do, is move this bend outside of this bend. And that's, again, the... Sorry, my brain does not work well even on the best of days. I'll just do it instead of explain it. We're going to tray, selecting it so we have design history on. And I edit this feature. Okay, and again I want to click symmetric. There we go. And now I can move this out a teeny tiny little bit. And it's going to do the same thing on the other side for me. I don't know how much that was, though. I'm going to have to pay attention when I click it. One, 3, 4, 5. 5 should be pretty good. Let's click OK and see what it looks like. 5's pretty good. We could go in a little bit. We could turn it to 4. But I also like this kind of even square we have. So I think I'd prefer to keep the square than to make the flange go more towards the bend. But we can tweak it before we're done here. I'm going to do the same thing on the front. It's lagging so bad. And you can see that Fusion automatically, because of the bin rules, will add a little relief notch once we go past a certain point. But we don't need to do that since we're so close to the edge. So it'll make it look better. See a Hyperion. Okay, front and back, we now have this little problem taken care of. And I'm going to do something else once we've finished making the model to make this even prettier. I'm actually going to use fillets or fillets. I don't really know what you want to pronounce it as. I've heard it said both ways by machinists. and make this a little bit smoother and rounder. But now we know that at least these flanges are real life compatible and can fit in the case. But we got to do the bottom ones now. So I'm going to select the cover. Four. Nice square. One, two, three, four. Okay, so now it's actually possible to assemble this case. But now we have these ugly gaps, and I want to fix those ugly gaps. And I've forgotten how I normally do this, so bear with me. I may be able to just extrude this out. No. I can't do that. I might have to make a sketch for it. I could cheat and look at something I've designed in the past too. But it's little stuff like this that makes everything look so nice when it's all done. Okay, that kind of works. It also means I'm going to have to change my reliefs over here, but that's fine. I'll do that in a bit. Let's add this to the other panels. So I just made a sketch on the edges. Easy peasy. Extruding these out. There's probably a better way to do this. If you know a better way to do this, you can certainly shout it out in the chat. My little arrow's missing. Got front, back, back here, one more. Oops, that's not what I meant to do. Cool. Yeah, okay. So now that I've done that, I can see that my little cutout for my relief is no longer square, and I want that to look good. So I'm going to make a little change there. Sebastian says, can I extrude without this sketch? And actually, I can't do that in this case, because if I wanted to pull on that side, it's going to automatically adjust all the other edges because it's considering them a solid sheet metal part. So that's why I made the sketch there. I tried that earlier. It didn't work out, but that was my first thought as well. So I'm going to go back over now to my flange. Where are you? Right here. And I'm going to change this. I want it to be a little bit closer. I might actually be able to go full edge now. I don't think I will be able to go full edge, but I want to see what that looks like once it updates on that side. Now, why can't... That's a little bit odd. Do not know what happened there. That's so strange. Hopefully it will unfold in a second. We'll see. That looks a little bit more natural. Still need a little bit more, so I'm going to edit that. I know it's kind of boring getting lost in the details, but this is going to really make a big difference, I think, when the case is all together. So there we go. That's about right. Now to do the front and back. So go back over to the cover. Gotta go to the tray for this one, right? Was it 2mm? Let's look and see. No. Really anything, man. Really. Actually kind of looks okay from the front, but the side it didn't look good on. As long as they're matching now. They're going to be very tiny once we get it all folded together, but... Now, again, I'm going to go back when it's done. I don't want to do this now because it causes some problems when we are folding it. So if I need to make changes, it's not too good. But as you can see, I can actually change this hard edges to a fillet, which looks a lot cleaner than those jagged edges. Plus, it will reduce the chance of you cutting yourself on the edge. But I'm not going to do that till the very, very, very end of this process. Okay. We have our basic box. We'll add screw holes at the very end as well. Now we can move on to slightly more exciting things, but also not that exciting. And that is the rear I/O. The rear I/O is the #1 area that I see people who are making their cases for the first time. That's where they run into trouble, and that's where things get very sloppy very fast. You can start on a project, you're putting everything together, and this isn't even in designing in 3D. This is like doing a normal mod. But then when it gets that rear I/O, it's like, don't look at the back of my computer because it looks like a hodgepodge mess of mistakes. So we want to get it right. The problem is, to get it right in the past, you need to have very complicated, very custom, expensive tooling to be able to form the features you need. Like the Mini, for example, uses those. So I kind of thought about it for quite a bit and wanted to come up with a method of mounting graphics cards that everyone could employ. And I had Eric help me refine it and get the details working right. Well, he made his own set that work really well too. But this is what I came up with. Maybe it's here. It's 3D printable retainer keys. So instead of having to worry about specific bins for the tab to mate up with the back GPU flange and having to have punched, okay, they're called lance operations for those little keys to be held back into. Now we can just have straight up cutouts and 3D print a little part and bolt it together, and it's super solid. Let me show you what it kind of looks like. I don't know why this didn't unplug. I don't know what I'm doing. I'm trying to show you what it looks like here, but the camera looks bad and there's no lighting. I can just model it. So let's get to work on that. I'm going to change the opacity of this to 40. That looks good. Let's make our I/O cutout first. That'll be really simple. And this is so accurate that I can just basically trace it. I don't need to know any numbers, although you can find those numbers in the ATX Guidelines Handbook if you Google it. But I've modeled this before, so I don't need to worry about it. I'm just going to get kind of close. I know it's going to work out perfectly. I don't want to deviate too much from it. I'm going to click move my sketch a little teeny tiny bit. Okay, move this one a teeny tiny bit. That's fine. And I'm not actually going to fillet this sketch curve at all because it won't matter once it's laser cut out. You won't be able to see something that tiny. Woo woo! I'm going to hide my PC hardware before I do this extrude because I don't want to extrude and cut through my PC hardware. And we know the depth is 2 millimeters. I'm not going to do 10 because if we change something down the design chain, it's going to remember that cut and it might end up cutting through something else. So I want to keep it at 2. And now I'm going to unhide my PC hardware and we have our I/O cutout exactly where we want it to be in relation to everything else. So our motherboard's going to fit and bolt right nicely with our 8mm standoffs, which we figured out earlier on this stream. That problem is solved. Second problem, bigger problem, GPU. Now, by no means do you have to follow my numbers. There is room for tweaking, but this is how I go about doing it when I'm making it from scratch. I do have a sheet, I do have a reference of numbers that I use. I'll go back, maybe make some adjustments, but this will work out the box. So if you're using my GPU model that I have, which you can get on Patreon, which you'll be able to download by following the link in the description when I'm done with this stream. I'm going to click the back of my chassis. I'm going to make a box. I'm going to make a box about right here. Not very scientific, not very exact, but basically covering this GPU key plate. And I want to make the box starting at this angle. Not that angle, that point. That point of that obtuse angle. And I'm going to look and see what I did exactly here so I can not tell you guys on stream and have it be wrong. Oh, I can't see anything. All right. I do like this, so I'm going to use it. This number is 14. This number is 100. Now I'm going to position this how I actually want it. Even it up a little bit. So I can see it quite well. And then once that's over there, I know that my actual GPU ports aren't way out here in this bracket, right? They're not. That's not what they are. They're on the GPU. So we're going to move it over. I just put them out there to start so I can make sure to get it kind of centered over those GPU ports. This GPU is so long. Oh my goodness, it goes on for days and days and days. about 8. Okay. I'm going to make another sketch, make a line, and I'm going to make this line 6.5. I'm actually going to undo that. I'm going to make it right here on the edge. 6.5. This should be 100. And we said this was 14. And I'll trim this little line right here. And this is how I get my cutouts to be really good looking in real life. It's very difficult because modeling these parts up is difficult in CAD, at least for me, and you can't trust anything you download off the internet that you didn't measure yourself. But I've now made several dozen cases, more than that, using this method, and it works really well for me, and it looks really good, and the graphics cards fit. So I'm confident showing you this, even though it's really rough and rustic and non-scientific. And if there's a better tutorial out there, definitely follow it, but this will make all my ports line up quite nice from my past experience. I'm going to finish my sketch. I'm going to hide my hardware here. -2. Cool. So now I have my cutouts for my I/O. And I want to make a cutout for my PCIe flange, the mounting flange right here. Oh, I normally do that. I think I said 8 millimeters away. And that worked out really well, just right at the top. So I'm going to do that again. It's going to have to be covered. So let's do it. I'm going to make yet another sketch. I'm going to start from behind my flange because it needs to poke through. And we got to go up a teeny tiny little bit. It doesn't need to be a lot, but again, I like to have, this is a millimeter, I like to have a little buffer. What's the word I'm using? Tolerance built in for actually installing this. Now on the bottom, it needs to be more because it needs to fit this to this tab right here, or the end of this. So sorry for my terminology. It needs to line up with the GPU PCIe bracket at the bottom. Now you might ask why that is. It just is going to fit when you go to install it a lot better. And we do need a little bit of space over here. I think 10 is going to be enough, but it depends on the thickness of the retainer, the key retainer that I'm using, which may be between 10 and 15 millimeters. I'm actually going to just say that this is 44 and that, oops, and that this is going to be 10. And if I need to make it wider, I will in a minute. But again, like if I want to install the GPU slightly at an angle, pushing into those retainer keys, then I need to have enough room for that flange to clear. It can't just be a slit. Now, as I said before, the way that we're doing this, you actually could back the GPU in straight and have a little slit, but that's not going to matter anyway because we have this retainer key. So I'm going to hit enter. I'm going to hide my hardware again. Got my cutout. Unhide my hardware. And now I have my hole. Oh, Michael's saying next time you're there, stop by and see us at Accurate Edge. And Accurate Edge is awesome. They are a water jet supplier, and I've actually had some of my pieces made by them in the past. But absolutely, if you are local, get your stuff done at Accurate Edge for sure. You can actually have this whole case made at Accurate Edge if you are local, because I'm going to give you the files and then you can give it to them to cut it. So Thumb will ask, where did I source the GPU model? I model everything that I build because I got to make sure that I have accurate numbers. The Sapphire model, I actually do designs for Sapphire. I help them out with stuff. They send it to me. I'm actually doing this build for Sapphire. I'm going to do the whole entire case, paint it, make it pretty, and they're going to give it away. But that's the quick answer. The answer you probably wanted was you can download a lot of models at GrabCAD. You can download models from BitTech and Hard Forum and Small Form Factor Forum. But just remember, anything that you download off the internet, you have to double check, because you do not want to spend a bunch of money cutting out panels and parts and find out that the person who modeled it didn't actually do a really accurate job. So I do have models myself available on my Patreon. And again, you'll be able to download this file and you'll have these access to most of these models in the YouTube channel below. It's a very popular question tonight. Okay, so this is the Magic Secret Sauce tab, which you'll be able to download, but this allows you to make your own computer cases at home. Without this, you would need special tooling. You need a special machine to bend out the tab and the flanges and the lance operation. But this, you can just 3D print, which is really, 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 really cool. I'm really excited about it. And I want to include NFC Eric on this too, because he made his own version. I don't have that here. He thinks it's better. I think mine's better, but you can you can go download them both. I'll put a link in the description, and you can use what you need, what works best. You know, I have to give some credit to me, because he just blows me away with all his inventions at NFC. He's the smart one. So whenever I have one up on him, you know, I gotta. I don't know why it's not inserting. Oh, there it is. Hello, way up there. Now, originally, I was thinking about patenting this. It definitely is patentable, because I don't want a big company to take it and then basically sue all of you guys for using their intellectual property. But I'm trying to get this out here as much as I can. I'm going to try to make it not open source, Creative Commons, something like that, just so we can have this file available to us and use it in professional designs, because this is a game changer. This is an absolute game changer to be able to make your own computer case at home, have places like Accurate Edge or SendCutSend make the part out, and then 3D print this to attach your GPU. Huge game changer. No special tooling, no special equipment required. Big, very, very big deal. I've been making computer cases since 2007 from scratch. And this, I wish I thought of this in 2007. So laggy. So you see how this works. Really, really simple. Basically, there's these two little nubs, and they go into the screw mounts of the GPU tab flange, and they actually print off pretty strong. I print them on my Markforged, which is that chopped carbon fiber. It's not my Markforged. Sorry, I rent it from Compact Designs. It's Craig's Markforged. But I print them off, and it's very, 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 very durable. And I couldn't believe how durable. When I first did this design, I was like, okay, let's just test this out, see if it works. It's probably going to break right off. It doesn't. It holds amazing. So it fits into those little holes on the GPU key and then just bolts to the case. And it holds that GPU in really, really well. It works out phenomenally well. And we're good to go there. But there has to be a second part to this, right? Because we can't just have it pushing against that sidewall. It's still going to be able to pop right out. So that's where the retainer key comes in. And this is a very simple part. I'm doing this 100% wrong. But par for the course. Eric is the one who is the Fusion 360 master. Why isn't he doing this live stream? He's even better looking than me. And he has an awesome airplane manager voice. Sounds like a fighter pilot. My computer is just dying. It's like, no, please stop. I don't want to move these parts anymore. We're almost there, though. I want to line this up, of course, with my side of the wall. And now I got to line this up from the front. Where did it go? Oh. That's about right. Let's make sure that it is right. It's not right. Beautiful. And you see how this works, right? So it's just a 3D printed part. On the Mark IV, this part will be super durable. Maybe you want to modify it if you have a really bad 3D printer, make it a little bit bigger. But again, like I thought this was going to break right off. So strong, can support these huge graphics cards better than the metal lances that I use. Phenomenal, just great. And the bolt goes right through the case, screws right into the plastic. Super simple. This mount holds the graphics card really, really well. Now, of course, it's going to flop down towards the bottom because it's such a long graphics card. It'll be supported a little bit by the riser ribbon, but we're going to fix that later in the design by making a bracket to hold the graphics card from moving up and down. Now, if you have a short graphics card, the riser will keep it from doing that 100%, but this graphics card is going to be massive. I'll actually grab it for you. Here she is. This is the Nitro Plus 6800 XT. Big boy. Sebastian says, what I print out of Onyx, which is a nylon chopped carbon fiber mix on the Mark Forged Mark II. D. Gave says, anyone printed a Skyreach 4S? Yes, there's a couple people that have done that. Some really good examples of it. I have to find some. I'll put them in the Discord later. they had to make some modifications, of course, since the Skyreach really isn't 3D printable by itself. It's so compact that if you just print out plastic, it wouldn't hold any parts together. But there are some good examples. And there is a company that specializes in making the Skyreach 4 Mini using 3D printing to rip me off. So it does work. Thelma says, I was stupid and got a 3090 Founders Edition. It's big. Yes, I have that as well. And it is a monster. An absolute monster. Super heavy. Super big. Ugh. But this project is for Sapphire. So I'm going to be using their card. Okay, this is great, guys. Because now we have our clamshell design. We have our mounting for our motherboard. Our standoffs. We know where the I/O is going to be. Oh, that's another really difficult thing to know. How do you know where to put the I/O cutout in relation to the motherboard? Well, you follow the ATX standard guidelines, which you can Google, or you can download the 3D model that I have on my Patreon or in this YouTube channel. So that's how you know the relationship between those two. But otherwise, it's a difficult thing to figure out. Now, if you want to know what relation the graphics card is normally, like when it plugs in, I have a 3D model of an ATX board as well, and you can orient them the correct way, socket them together, and it'll be super accurate. So that's one way to figure that out. Also, there is a 3D model on the internet that somebody did that's super accurate that I'll link to in the description below. It's been ripped off so many different times. I don't know who originally made it, so otherwise I'd give them credit, but it's really well done. All right, this is literally a case, and it would be a good stopping point, but I think I'm going to keep pushing forward a little bit further. I do want to make another stream, though, where I finish this up and add all the cool features and make it look really awesome. But there's no way that I can do this for another 3 hours. What are some things I do want to do? I do want to add a cutout to the top. I don't want to add holes yet because I'll slow everything down. I can't add a couple holes though. I need to make a power supply bracket. I've actually made a power supply bracket. I'm just going to steal one from there. Let's put that in here. Click this. Oh, here it is right here. Cool. Jonathan Doe, I am building a case around the Sapphire Nitro Plus 6800 XT. The model I'm using is the 5800 XT that I finished for the last Sapphire project, but the dimensions are very, very similar. So now that I have it close, I'm actually going to use the point-to-point tool. So I'm going to select my inside point on my bracket, select my outside point on the PSU, power supply, click OK, and now the bracket's exactly where I want it to be. I've already previously made this bracket. It's going to work for this case. That's why I just did there. Now you'll notice that my 2.5-inch hard drive mount is pushing into the graphics card, and I could fix that by moving the graphics card out a little bit more, but I'm not going to use 2.5-inch drives on this computer case. So I'm not really going to worry about that. I'm just going to leave it exactly how it is. But if I wanted to make that change, I will show you in case you guys want to add that later. I suppose I'll do that. So I'm going to go over the PC hardware. And I'm going to click this, 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 and this. And move it not that far. It's lagging so bad. Don't deselect. 5 is what we were aiming for. 5 millimeters. And of course, we got to move our cutouts that we made 5 millimeters too. So I'm going to click on our tray, design history, hide my hardware, and move it by selecting the edges. Now, I don't really think this is the appropriate way to do this. I think you would probably want to do this a different, more professional way. But I don't know that professional way aside from working with sketches. But I know that Fusion 360 does not really like working with sketches once your model gets detailed and you're doing a live stream with the 2 USB devices to make the live stream work. So, you said 5. Okay. I don't think that moved it out too far, did it? Let's see if everything still works. Cool. Everything fit. I had enough clearance for the C6 connector. I guess I'll leave it like that, not because I need it, but in case you guys want to throw in 2.5-inch drives with a long graphics card, now you can. That bracket supports it. So, Harry Taylor asks a very good question. He says, any reason you're manually aligning the parts rather than using joints? Now, I've said this before, I'll say it again. I am not an expert in Fusion 360. I do a lot of things wrong. But one of the things that I do, my process, is I will make a new file. I call it my master file. This I named Sapphire Quarter 4. But basically I make a really dirty model. And I throw everything in the model. I arrange them kind of how I want them to be arranged. So I can do my tweaks, do my sheet metal, do my features, do my cutouts. And then when I'm done, I export all the sheet metal cleanly into another folder. And from there, I assemble everything with joints, which is really important for like doing things like exploded views, making sure everything lines up correctly. I do use joints. I just use them later on in the design process. But starting off, it just works better for me to do it this way. Now, NFC Eric, he designs things completely different than I do. He does everything in sketches, one part at a time, and then assembles it, and then goes back to his sketch and edits the sketch to move things over. On my head, I can't comprehend that. I used to be a 3D designer that made like levels for video games using those kinds of tools. So working with a completely different way of modeling is difficult to me. I used to be a master of Hammer, Radiant, the Unreal Engine. So those work a lot differently. Maya, way back in the day, I couldn't even work Maya today if I wanted to save my life, but I hope that makes some sense. But again, I'm not teaching people how to use Fusion 360. That would be really stupid. There's great tutorials online. I'm just showing my design process for all the major steps of how I want to arrange hardware and put the case together and plan for bins, folds, how things bolt together, cable runs, that kind of stuff. I'm almost at my first, I think, stopping point. I don't know where I want to put my on-off switch. I might put it here at the bottom if I can move it over enough. That might kind of look pretty cool. I know that I'm going to have this case be vertically standing, so I'm fixing at this point now to change it to that. So I forgot that I have to, can only choose front. I know that the graphics card is going to be the top because I want to show it off for Sapphire. So this is going to be my front. I'm going to make, instead of vents for the back, I'm going to make like a window, I think, to really show off the graphics card. I might have a straight cutout. I might make some kind of beveled 3D printed part. I'm not exactly sure. I want to save that kind of design stuff for tomorrow, or when I do my next stream to finish this off. But what other structural things do I need to cover before I end it here? I'm going to add all my holes for everything at the very end. That's really important to me. Otherwise, I get messed up when I start to actually account for them. I'll add the cooler in later when I figure out what cooler I want to use. And I'm going to make a big window on the top. I think I'm going to make the window first. And then when I go back, I'll make the actual panel. Excuse me. So I will add a cutout right now. So let's do that. Jose says, we'll have a GPU support piece. Yes, it's going to have a support piece. It's going to be supported a little bit by the riser, but I'm going to be making a support bracket. You could probably do the support bracket now. That's probably a good thing to do. Did I press hole? What am I doing? No, go back over here. Change my opacity to 50%. Okay. I don't want to be showing off the edge of the cables. I don't want to show off my AC cable run. I don't want to show off all the nasty power cables at the edge of the board. I don't really want to even show off the whole card. Because if I show off the whole card, if I look underneath it, I'd like to come from the top, because if I'm looking at it from a perspective type view, I want the card to only see card. So I'm actually going to come in a little bit. It says 24. We're going to say 25. Wait, what? Did it do 2? No, that was the x-axis. That looks about right to me, and that's almost an inch. I do want to have enough space in case I use a really tall cooler. I'm going to keep it at 25. I'm going to go -2, so I don't be chopping through my other parts. I'm going to turn my opacity back up. I probably, now that I'm looking at it, I might make some kind of bridge so I can cover the cables and also this riser, and that will make everything look a lot neater. And then maybe put the Sapphire Nitro logo right here. That could look kind of cool. I'll throw that in there for now. Well, do I want to make that out of the top part or another cover panel so I can paint a different color? Kind of an interesting thought. Because if I make it out of the cover panel, I put a window on top of this, it's going to sit completely flush. I'll do it for right now, and then I can change it to next time we do a stream if I need to do it that way. Again, the magic of Fusion, I can go back in the timeline anytime I want to. But I forgot I do need to change the opacity because that apparently is not. Uh, 75. I like nice even numbers. Can't do anything about the other one because it's an offset. And now I need to cut this out. So I'll take this and come about right here and make this 30. And I'll use the trim tool and trim out my lines. That's not what I wanted to do. I want to keep that for sure. Okay. And when I'd come back later, I'd add fillets to the sketch to smooth that out, and then put the window on top. But I think it's going to look a lot cooler actually now that I do that if I have this entire frame open and then make another bracket that comes up and goes over. And actually, now that I think about it, if I did that way, I could build the flex bracket right to the GPU, the anti-flex bracket, come over one of these holes, use an extra long M2.5 screw, and that will give it some support. So I think that's the way that I'm going to roll. I should have created another sketch so I didn't have to do it that way, but -2. Cool. All right. I'll answer some questions before I take a break for today. And I got to finish this quickly, so I'll be working out tomorrow. I'll do a stream as soon as I get on and start doing it. Don't know the exact time. People are asking about vents for intakes and stuff. I'm going to add lots of vents to this thing. I'm going to be adding... It's going to come alive in the next stream, and you'll see how cool it's going to look. Right now, it's very boxy. It's very formal, but we need a base to start working off of. And once we have that foundation, that's when we can come in and we can add all the cool stuff that makes it an awesome computer mob. As far as the thickness, people I think were asking about it. I'm probably going to make this out of 1.6 millimeters aluminum, 5052 aluminum. However, in the model right now, it's 2 millimeters. But I can change that rule in going back. What Silverstone power supply do I use? I use the Silverstone 700 Platinums. And this is obviously an SFX, not an SFXL. I will be using an SFXL for this build because I have the room. I'm not going to be using 2.5-inch hard drives, but if you want to use 2.5-inch hard drives, I have this bracket right here, which I'll include this whole model in the description below. But it wouldn't be compatible, obviously, if you wanted to use those drives. But any more questions before we call it for tomorrow? Tomorrow's where it's really going to start to look really cool. Do I recommend 6082 T6 for PC cases? Absolutely not. Absolutely not. If you're bending it yourself, it's going to crack. It's not going to look good. You're not going to get the bends that you want. And working with a manufacturer, that requires, again, special tooling. You're going to have a really serious press brake with very sharp, brand new dies in order to get good parts out of 6082. So I really, really, really recommend 5052 aluminum for a computer case. David Banner asks, what time tomorrow? I really don't know, man. I got a lot of stuff to do. I just know that this is a priority to me to finish up this computer case. So I'll just start when I start. But I really appreciate you guys joining in and asking questions. I'll scroll through here and see if I see anything extra. I think I got most everything. Average watch time, 2 minutes, 58 seconds. Yeah, it's kind of boring if you're not trying to do this yourself. All right, I love you guys. Peace. God bless. I'll see you tomorrow. And we will make this thing into a real mod.